What if you could travel through time? Imagine stepping into a machine, twisting a dial and being transported to another era. Would you journey to the past, witnessing historical events firsthand? Or would you venture into the future, catching a glimpse of what's to come? Time travel has captivated the human imagination for centuries, inspiring countless science fiction stories and sparking endless debates among scientists and philosophers alike. But is time travel truly possible? Could we one day unlock the secrets of time and bend it to our will? The answer, as with many things in the realm of science, is a resounding maybe. To understand the concept of time travel, we must first grasp the nature of time itself. Time is an ever-present force that governs our lives, yet it remains one of the most enigmatic aspects of our universe. From the ticking of a clock to the changing of seasons, time is a constant companion, guiding us through the tapestry of existence. Time is often described as a linear progression, flowing from the past through the present and into the future. This linearity is something we take for granted, as it forms the basis of our daily routines and long-term plans. We mark our calendars, set our schedules, and live our lives according to this seemingly unbreakable flow. We experience time as a constant, unwavering march forward, each moment leading inexorably to the next. This perception of time as a relentless forward motion is deeply ingrained in our consciousness, shaping our understanding of cause and effect, and influencing our decisions and actions. However, physicists have come to understand that time is not as straightforward as it seems. The nature of time is far more complex and mysterious than our everyday experiences suggest. It is a concept that has puzzled scientists and philosophers for centuries, leading to groundbreaking discoveries and theories. Albert Einstein's theory of relativity revolutionized our understanding of time, demonstrating that it is not absolute but rather relative to the observer's frame of reference. This groundbreaking theory revealed that time can vary depending on the speed at which an observer is moving and the strength of gravitational fields they are experiencing. This means that time can be stretched and compressed, warped and distorted depending on factors such as speed and gravity. The faster you move, the slower time passes for you relative to someone who is stationary. Similarly, the stronger the gravitational field you are in, the more time will slow down. These mind-bending concepts have opened up new possibilities for understanding the universe and the potential for time travel. This malleability of time forms the basis for the possibility of time travel. If we could somehow manipulate the fabric of space-time, perhaps we could create shortcuts or loops that would allow us to jump forward or backward in time. While the idea of time travel may seem like pure science fiction, there are several intriguing theories that suggest it might not be entirely outside the realm of possibility. These theories often involve exotic concepts such as wormholes and time dilation, which we'll explore in more detail later. One of the most popular concepts associated with time travel is the idea of wormholes. Imagine a tunnel connecting two distant points in space-time, allowing you to travel between them much faster than you could by traversing the vast expanse of space in between. These theoretical tunnels, known as wormholes, are predicted by Einstein's theory of general relativity. They are thought to be formed by the intense gravitational fields of extremely dense objects, such as black holes. However, the existence of wormholes remains purely theoretical, and even if they do exist, it's unclear whether they could be used for time travel. Section 5. Time dilation. Time is not absolute. Another fascinating aspect of Einstein's theory of relativity is the concept of time dilation. This concept fundamentally challenges our everyday understanding of time as a constant, unchanging flow. Instead, it reveals that time can stretch and contract depending on various factors such as speed and gravity. This phenomenon predicts that time passes slower in stronger gravitational fields and at higher speeds. Imagine a clock placed near a massive object like a black hole. The intense gravitational pull would cause the clock to tick more slowly compared to a clock far away from such a gravitational influence. For example, time passes slightly slower for astronauts aboard the International Space Station than it does for people on Earth due to their high orbital speed. This effect, although minuscule, has been measured and confirmed by comparing the time on atomic clocks on the ISS and on Earth. While the time difference in this case is minuscule, it becomes more significant at speeds approaching the speed of light. As an object moves faster and faster, the time experienced by that object slows down relative to an observer at rest. This means that if we could build a spaceship capable of traveling at near-light speeds, the effects of time dilation would become dramatically noticeable. If a spaceship could travel at near-light speeds, time would pass much slower for the passengers compared to those on Earth. For the astronauts on board, a journey that might take thousands of years from the perspective of someone on Earth could be experienced as only a few years or even months. This means that a journey to a distant star system that would take thousands of years from Earth's perspective could potentially be completed within the lifetime of the crew members. This opens up fascinating possibilities for interstellar travel and the future of human exploration, as time dilation could allow us to reach distant corners of the universe within a single human lifespan. Section 6. Time travel in science fiction. Time travel has been a staple of science fiction for decades, inspiring countless stories and capturing the imaginations of readers and viewers alike. The concept of moving through time, whether to the distant past or the far future, has fascinated humanity and provided a rich canvas for storytelling. From H.G. Wells's groundbreaking novel, The Time Machine, which introduced the idea of a machine that could travel through time, to the iconic film franchise Back to the Future, which brought the concept to mainstream audiences with its thrilling adventures and memorable characters, time travel has provided fertile ground for exploring the possibilities and paradoxes of manipulating time. These narratives often push the boundaries of our understanding of time and challenge our perceptions of reality. These stories often delve into the ethical and philosophical implications of time travel, raising questions about the consequences of our actions and the nature of destiny, such as the potential for altering the past, which could have unforeseen and potentially catastrophic effects on the present and future, or creating paradoxes that could unravel the fabric of reality. The idea of a time paradox, where actions in the past could negate the future, adds a layer of complexity and intrigue to these stories. While entertaining, these fictional depictions of time travel often take creative liberties with scientific accuracy, bending the rules of physics to serve the narrative. This allows writers and filmmakers to explore imaginative scenarios without being constrained by the limitations of current scientific understanding, bending the rules of physics to serve the narrative. Despite the scientific inaccuracies, these stories continue to captivate audiences, inviting them to ponder the mysteries of time and the endless possibilities it holds. Section 7. The Grandfather Paradox. One of the most famous thought experiments related to time travel is the Grandfather Paradox. This paradox explores the logical inconsistency that could arise from traveling to the past and altering events that have already occurred. Imagine a time traveler going back in time and accidentally killing their own grandfather before their parent was even born. This action would seemingly prevent the time traveler from ever being born in the first place, creating a paradox. If the time traveler was never born, how could they have gone back in time to kill their grandfather? Section 8. The Butterfly Effect. Another intriguing concept related to time travel is the butterfly effect, which suggests that even small changes to the past could have significant and unpredictable consequences in the present. This idea is often illustrated by the metaphor of a butterfly flapping its wings in Brazil, potentially causing a tornado in Texas weeks later. While the butterfly effect is often associated with chaos theory and weather patterns, it also holds implications for time travel. If even the slightest alteration to the past could have ripple effects that drastically alter the present, it raises questions about the feasibility and ethics of tampering with the timeline. Section 9. Is time travel possible? So, is time travel truly possible? The answer, unfortunately, remains elusive. While the theories of relativity provide tantalizing hints that manipulating time might be feasible, the practical challenges and potential paradoxes associated with time travel are immense. Some physicists believe that time travel to the past might be impossible, as it would violate fundamental laws of physics, such as causality. Others suggest that time travel might be possible but only under extremely specific and challenging conditions, perhaps involving technologies and energy levels far beyond our current capabilities. Section 10. The Challenges of Time Travel. Even if time travel were theoretically possible, the practical challenges of building a time machine would be astronomical. Manipulating the fabric of space-time to create wormholes or achieve near-light speeds would require immense amounts of energy, likely far exceeding anything we can currently generate or control. Furthermore, the potential dangers of time travel are significant. The paradoxes and unintended consequences of altering the past could have catastrophic repercussions, potentially unraveling the very fabric of reality as we know it. Section 11. The future of time travel. Despite the numerous challenges and uncertainties surrounding time travel, the human fascination with this concept is unlikely to fade anytime soon. As our understanding of physics continues to evolve and our technological capabilities advance, we may one day unlock the secrets of time and determine whether traveling through it is truly within our grasp. Until then, time travel will likely remain the realm of science fiction, inspiring our imaginations and fueling our curiosity about the nature of time, the universe, and our place within it.